Hi guys, welcome back to the channel. Today I'm going to show you how to solve for this electrical circuit. It might look challenging because of this EMF1 and EMF2, but if you follow these next steps, it will be quite easy to solve. The first step is to just see the voltages for each resistor. So we know this node over here will be 100 volts. This one over here is 50 volts. And this one over here is 0 volts. Now the next step would be just to see the voltages for each resistor. So now VR1, because it's in the 100 volt node, is just simply 100 volts. VR2, however, is also not just simply 100 volts, but because EMF1 is flowing this direction and EMF2 is this direction, VR2 will simply be 100 minus the 50 volts, and this is also 50 volts. And VR3 is simply, because it's in the 50 volt node and it goes to ground, is 50 volts. Now the next step would be just to solve the currents for each resistor. So we know IR1 is simply VR1 divided by R1, and this is 100 volts, divided by R1 is 16 ohms, and this is 6.25 amps. And IR2 for the resistor 2 is VR2 divided by R2, and this is the 50 volts over here, divided by 5, which is 10 amps. And the last current, IR3, simply VR3 divided by R3, and this is 50 volts divided by 12 ohms, and this is 4.17 amps. It's also very important to know that the direction of current flow. Since we know this current flow will be this way and this way, and if you take the current loop, this will be upwards. Therefore, this is minus 4.17 amps if you take the consideration of direction into account. Looking at the Kirchhoff's current loops now, let's just do that. So I1, simply this one over here, I1, and this would be everything entering is equals to everything leaving that node. Therefore I1 will be simply IR1 plus IR2, and this is simply, IR1 is 6.25 plus IR2, which is 10 amps, equal to 16.25 amps. And the next one we'll do is I2, so it's everything for EMF2. So I2 will simply be IR2 plus IR3, and IR2 is equal to 10 amps, and because you have to consider the direction of current flow for this, and we know that the direction for IR3 is minus 4.17 amps, it will be minus 4.17 amps, and this will equal to 5.83 amps. Now let's calculate the powers for each one of the resistors. So PR1 is equal to IR1 times VR1, and this is equal to 6.25 minus 100 volts, remember that, so it's 625 watts. And for PR2, it is equal to 10 amps times the voltage, which is 50 volts, and this is equal to 500 watts. Just remember to always put in the formula you're going to use. I just missed it there by accident. So resistor power for resistance 3x IR 3 times VR 3, and this will equal 4.17 times 50, and this would equal to 208.33 watts. Therefore the total power will be PR1 plus PR2 plus PR3, and this is 625 plus the 500 plus 208.33, and this would equal 1333 watts. You can also calculate the power using the Kirchhoff's current loops. Let's just also calculate that to make sure the two powers are equal. Therefore, PEMF 1 equals EMF 1, which is this 100 volts, times I1, which we calculated over here, and this would equal 100 times 16.25, and this is 1625 watts. Now let's do for PMF2, and this is EMF2 times I2. And because the voltage flows from a higher to a lower potential, therefore the power going in over here will be negative into this power source. So therefore it's minus 50 times 5.83. Therefore this will equal minus 91.5, sorry, 0.67 watts. Therefore P total would be PEMF 1 plus PEMF 2, and this will just simply 1625 minus 291.67, and this will also be 1333 watts. Therefore this power is equal to this power over here. So we know these are correct. So you can also say, using this power over here, that EMF2 is essentially charging. Because there's power flowing into this, because voltage is from a higher to a lower potential, and we know that the current is negative, therefore the EMF2 is charging. And I hope you guys enjoy this video and know how to solve this one for future.